This process begins with iron ore, not steel, not metal, just raw rock. Iron ore arrives from open pit and underground mines by truck and rail. Some pieces are large and dense, others arrive as fine granular material. Each shipment is weighed and sampled. Laboratories quickly analyze iron content to ensure consistency. Only ore that meets strict chemical requirements moves forward, because every fluctuation affects the furnace later. Once approved, the material enters the plant. The ore is still far too large to be used. Massive jaw crushers break it down under extreme pressure. Cone crushers and mills continue reducing size. The goal is uniform particles. Next comes beneficiation. Magnetic separators pull iron-rich material away from waste rock. Silica, dirt, and impurities are removed. Iron concentration increases significantly. Water sprays suppress dust and cool equipment. Particle size is continuously monitored. Now, the ore is ready to be transformed for the blast furnace.
By precisely tuning the electromagnetic frequency, we can achieve nearly 100% purity in the separation process.
Fine ore cannot go directly into a blast furnace. It would block airflow, so it must be reshaped.
The
Some
rotating
ore is
drums
sintered,
continuously
heated
shape
until
the fine
particles
ore
fuse
into
into porous
uniform
chunks.
spheres.
Other
A
material is
critical step in the
pelletized,
process.
rolled into uniform balls, and hardened in rotary kilns. Limestone and coke fines are added. They help control chemistry and furnace efficiency. The result is strong, breathable feedstock, built to survive extreme heat. Blast furnace never stops. Layers of sinter, pellets, coke, and limestone are fed from the top. From below, superheated air is blasted upward. Temperatures exceed 1500 degrees Celsius. Carbon monoxide forms and strips oxygen from iron oxide. Pure iron melts and flows downward. At the bottom, molten iron, called hot metal, collects. Above it floats molten slag. Both are tapped separately. The slag is removed. The hot metal moves on. Hot metal still contains too much carbon, so it enters the basic oxygen furnace. A lance blasts pure oxygen into the molten iron. The reaction is violent. Carbon burns away. Silicon, manganese, and phosphorus are removed. The chemistry is adjusted with extreme precision. Within minutes, iron becomes steel. Molten steel, clean, controlled, and ready for shaping. Steel flows from furnace to caster without stopping. It enters water-cooled molds, solidifying from the outside in. The result is a continuous steel strand. This strand is cut into billets, long square blocks of glowing metal. Cooling must be controlled. Too fast causes cracks. Too slow wastes energy. Once cut, billets move directly toward rolling. Billets must be reheated before rolling. They enter reheating furnaces reaching 1200 degrees Celsius. The steel softens. Internal temperature becomes uniform. This step is critical. Uneven heat leads to deformation later. When ready, billets exit glowing orange. Now the steel is shaped. Billets pass through a sequence of rolling stands. Each stand squeezes the steel smaller. Square becomes round, thick becomes thin, short becomes extremely long. The steel accelerates rapidly, reaching speeds over 100 kilometers per hour. Scale flakes off, sparks fly, diameter is controlled within fractions of a millimeter. By the final stand, the billet has become wire rod.
The efficiency metrics are exceeding projections by 5%.
That's exactly what we wanted to see. Keep monitoring the weld points closely.
Fresh wire rods are still extremely hot. They pass through controlled cooling systems. Air and water regulate temperature precisely. This step defines the steel's final properties: strength, flexibility, durability. Too fast, and the steel becomes brittle. Too slow, and performance drops. Cooling locks the internal structure in place. The wire rod is now continuous and flexible. It is guided onto rotating coilers. Large coils form rapidly, often weighing more than a ton each. The coil pattern must be perfect. No overlaps, no twists. Each coil represents kilometers of steel wire. Every coil is tested, diameter measurements, tensile strength tests, surface inspections for cracks. Defective coils are rejected and recycled. Only compliant product moves forward. Finished wire rods are stored and shipped. They become construction wire, bolts and fasteners, springs, steel cables, reinforcement products. From raw iron ore to high-speed rolling steel, this factory runs non-stop, 24 hours a day, turning rock into precision steel at industrial scale.